Hello, welcome again. We are solving some questions of machine design. Topic is friction in screw, bearing and clutches. Question number 2 is a square threaded bolt with a core diameter of 25 mm and a pitch of 10 mm is tightened by screwing a nut. The mean diameter of the bearing surface of the nut is 60 mm. The coefficient of friction for the nut and bolt is 0.12 mm, and for the nut and bearing surface it is 0.15. Force required at the end of a 400 long spanner if the load on the bolt is 12 kilonewton. Option A 151 Newton, option B 218.7 Newton, option C 250.8 Newton, option D 175.1 Newton. So this is your square threaded bolt. So in the square threaded bolt, so this is your D mean diameter, and this portion is square. That's why it is called square threaded bolt. And this distance between the corresponding point on the thread is pitch. So this will be pitch by 2. Okay, and as this is square, so this will be pitch by 2. So outer diameter will be d core plus p by 2 plus p by 2, and mean diameter will be average of d mean and d outer, that is d mean plus p by 2. So uh, in case of square threaded bolt, the mean diameter of the threaded bolt is core diameter plus pitch by 2, that is in this case it is 30 mm. And now as the as this can be as lifting in the screw can be compared with the with your with inclined plane. So in one rotation of the screw, that is in one rotation of the screw will move horizontally by a distance pi d and will move up by a distance of pitch. So p by pi d represents uh, P by pi d represents tangent alpha, and this is here in screw threaded bolt it is called helix angle, and in inclined plane it is called inclined plane angle. So helix angle and inclined plane angle are comparable, so these are almost same. Okay, so that is the horizontal distance level, that is pi d, and p is your vertical distance level. Okay, so tangent alpha is your pitch by pi d. So pitch is your 6 and diameter is your 30. So alpha tangent alpha is your 0.0636 and alpha is your 3.64 degree. Okay, so helix angle is 3.64 degree. Okay, and tangent pi. Sorry. Now we have determined helix angle. So now the friction between nut and bolt is 0.12. So the friction angle is tangent pi is equal to 0.12, can be calculated friction angle like this, because friction coefficient of friction is given as 0.12. So the friction angle is your 6.84 degrees. Okay, now if we apply a force along if we apply a force here, okay, to rotate the screw or to lift the nut or at the circumference of the mean diameter, okay, then this force is given by F is equal to W tangent alpha plus pi. Alpha we have calculated, that is 3.64 degree. Pi we have calculated, okay, and W is given as 12,000 Newton. Okay, so that is the force required at the circumference of the mean diameter. Okay, so now if we multiply it by R, then it will be torque required to lift the load. So that comes out as 33297 Newton. So now this is the torque required when lifting of the screw is carried out, lifting of the weight is carried out with the rotation of the weight. Okay, so let us read this. Torque T1 is used to move the load up when only T1 move the, okay, torque T1 is used to move the load up when only T1 is applied. Okay, the load rotates with the screw. Okay, so when only this torque is applied or force is applied, so then so load is placed here. Okay, then the load will rotate with the screw. Okay. Then the load rotates with the screw. To prevent this rotation, load is placed on the bearing. Now if we place a bearing here, okay, that does not rotate with the screw, and place the load on the bearing, then its rotation can be prevented. But then there will be friction between the screw and bearing. Okay, so to prevent this rotation, the load is placed on the bearing which does not rotate with the screw. Okay, and this bearing is then placed on the screw. The load is placed on the bearing and bearing is placed on the screw. Okay, and does not rotate due to friction between the screw and bearing. Okay, as it is not rotating with the screw, so to prevent its rotation, uh, some torque has been applied. Has to because some torque is used to overcome the friction, or some torque is wasted in friction. So that amount of torque is given by T2, and that we should also take into account, because this torque T1 is required when lifting of weight with the rotation of load is required, because here no rotation of the load is required, so a bearing is placed in between and the load is placed on the bearing, and bearing does not rotate with the screw. So as bearing does not rotate with screw, so there will be some torque lost in this bearing and screw, as the coefficient of friction between the bearing and screw is or nut is given as 0.15. Uh, so now this and mean radius of the bearing is given as 30, diameter is given as 60 mm. Okay, and so the torque consumed in overcoming that friction is mu WR, or W is load. The load is on the bearing. Okay, and so that will be your 0.15 into 12,000 into 30. So that is T2 is equal to 54,000 Newton mm. Okay, and this torque is your when the rotation is required is this. So to prevent the rotation, the torque required is this. So total torque required is this plus this, because this is for lifting, this is to prevent rotation. Okay, so total torque required is your 87296 Newton mm. Now we have considered that the load is in first case the load is applied here. Okay, and in second case, suppose bearing diameter is like that, this is 30, load is applied here. Okay, and we have calculated torque correspondingly for this load and for this load. Okay, and so now a spanner is attached. Spanner is of 400 mm length up to this. Okay, now we have to apply force so that it can create same torque as we have calculated. So suppose that the force applied at the end of spanner is F dash. Okay, and if we multiply by L, then it is creating same torque. Okay, so L is your 400, so F dash is your 218.7 Newton. So answer to question number 2 is your